Hello everyone. Welcome to my channel where I talk about all things related to Arduino and electronics. In today's video, I'm going to explain what sensors are, how they work, and what are some different types of sensors that you can use with Arduino. Sensors. Basically, sensors are the devices that can detect physical phenomena such as light, temperature, motion, sound, etc., and converts them into electrical signals that can be processed by a microcontroller. Such as Arduino, sensors are essential for making interactive and smart projects such as robots, alarm, thermostats, and many more. You can see in this particular example, when a ball is coming, there is a sensor placed. That sensor is sensing that ball, and accordingly that information will be provided to the system. So in this way, when some particular obstacle is coming in between, then the sensor will detect and give the information to the system, and accordingly the microcontroller will act. There are different type of the sensors available in the market which can be used, as I said earlier. Let's move further and see different types of the sensors. There are two main types of sensors, direct and indirect. Direct sensors measure the physical quantity directly without any intermediate conversion. For example, a potentiometer is a direct sensor that measures the rotation angle of a knob. Indirect sensors measure the physical quantity indirectly by converting it into another quantity that can be measured. For example, a thermistor is an indirect sensor that measures the temperature by measuring the resistance of the material that changes with the temperature. You can see here in the diagram, there are different type of sensors available, which can be direct sensor or indirect sensors, like the rain sensor, PIR sensor, water flow sensor, IR sensor, thermistor, ultrasonic motion sensor, gas sensor, etc. Now let's look at some different types of sensors that you can use for your projects. I will explain how each sensor works, what are its applications, and how to connect it with Arduino. I will also show you some examples of code that you can use. So let's move further and see different types of the sensors. The first sensor that we are going to talk about is the infrared sensor. The infrared sensor is an electronic device that measures and detects infrared radiation in its surrounding environment. An infrared sensor can detect infrared radiation, which is a form of electromagnetic radiation that has a wavelength longer than visible light. Infrared radiation is emitted by any object that has a temperature above absolute zero, such as humans, animals, fire, etc. There are two types of infrared sensors, active and passive. Active infrared sensors emits infrared light and measure the reflection from the object. They are used for distance measurement, obstacle detection, and line following. Passive infrared sensors do not emit any light but only detect the infrared radiation from the object. They are used for motion detection, security system, and remote controls. To connect an infrared sensor to Arduino, you need to connect the power supply pins VCC and ground to the 5-volt and ground pins of Arduino respectively, and the signal pin, that is called as out pin, to a digital input of Arduino from 0 to 14. You can use the digital read function to read the state of the sensor, which will be either high or low. Depending on whether the sensor detects infrared radiation or not, you can also use the pulse in function to measure the duration of the pulses sent by the sensor, which will vary depending on the distance or the motion of the object. This was all about the infrared sensor, that is also called as IR sensor. Let's move further and we'll talk about the next sensor, that is temperature sensor. A temperature sensor is a sensor that can measure the temperature of an object or the environment. There are many types of temperature sensors available, such as thermistor, thermocouple, RTDs, etc. One of the most common and easy to use temperature sensor with Arduino is LM35. Even there are digital sensors like DHT11 and DHT22. The LM35 sensor, which is not commonly used to connect with Arduino, is an analog sensor that outputs a voltage proportional to the temperature in degrees Celsius. To connect the temperature sensor to Arduino, you need to connect the power supply pins VCC and ground to plus 5 volt power supply of the Arduino and the ground pin of the Arduino, and the signal out pin, the third pin of the TMP36 or TMP35, is to be connected to an analog input pin of Arduino. Here you need to consider, or here you need to keep in mind, that we are connecting that output pin, the signal output pin of this TMP35 or TMP36 to the analog input pin. You can use the analog read function to read the values of the sensor, which will be 0 to 1023, corresponding to 0 to 5 volts. To convert this value in degrees, you need to multiply it by 5, divide it by 1024, and multiply it by 100. This is the way how we can use the temperature sensor in Arduino circuits. Moving ahead, and we are going to talk about the next sensor, which is a proximity sensor. A proximity sensor is a device that can detect the presence or absence of an object in its vicinity without any physical contact. Or you can say a proximity sensor is a sensor that can detect the presence or absence of an object near to it without any physical contact. There are different types of proximity sensors, such as capacitive, inductive, ultrasonic, etc. One of the most common and easy to use proximity sensor with Arduino is HCSR04, which is an ultrasonic sensor that measures the distance of an object by sending and receiving sound waves. Here, the proximity sensor VCNL4010 is shown through the diagram in this particular example. To connect a proximity sensor to Arduino, you can connect the power pins VCC and ground to 5 volt and ground respectively, and the trigger pin TRIG and the echo pin ECHO to the two different digital pins of Arduino. You can use the digital write function to send a pulse to the trigger pin and the pulse in function to measure the duration of the pulse received by the echo pin. To calculate the distance to the object, you need to multiply the duration by the speed of sound, that is 340 meter per second, and divide it by 2 since the sound travels back and forth. So in this way, using this proximity sensor, we can measure the distance. Moving ahead with the next type of the sensor in our basket, and that is ultrasonic sensor. An ultrasonic sensor is a sensor that can sense or that can measure the distance to an object by sending and receiving sound waves at a frequency higher than the human hearing range. Ultrasonic sensors are the type of proximity sensors, but they can also be used for other applications, such as measuring the level of liquid, the speed of vehicle, or the position of robots, etc. Here is the diagram of ultrasonic sensor where we are using HCSR04 SRO04. This is most widely used ultrasonic sensor in Arduino. The HC SR04 is an example of the ultrasonic sensor, and it can connect it to Arduino in the same way as explained previously for the proximity sensor. Talking about the next sensor, that is the accelerometer sensor. This accelerometer sensor is a sensor that can measure the acceleration of an object along one or more axes. Acceleration is the rate of change of velocity, and it can be caused by gravity, motion, or force. Accelerometers are used for various applications such as detecting the orientation of a device, measuring the vibration of a machine, controlling the movement of the robots. One of the most common and easy to use accelerometer sensor with Arduino is ADXL335, ADXL335 or ADXL345, which is an analog sensor that outputs a voltage proportional to the acceleration in three axes X, Y, and Z. The sensor has a range of plus minus 3g, where g is the acceleration due to gravity, and that is 9.8 meter per second square. To connect the accelerometer sensor to Arduino, you need to connect the power supply pins VCC and ground to 3.3 volt and GND pins. Here, one thing you need to keep in mind while using this accelerometer sensor is that in earlier sensors, we were connecting the power supply pin with 5 volt, but here we can connect it with 3.3 volt power supply, which is given on the Arduino board. And the signal pins X, Y, and Z to 3 analog input pins of Arduino. So we can use here A0, A1, A2 analog input pins of Arduino, and we can connect these X, Y, and Z axis pin with that. You can use the analog read function to read the values of the sensor, which will be 0 and 1023, corresponding to 0 and 3.3 volts. To convert these value into the gravitation, you need to subtract the offset value, multiply by 3.3, divide by 1024, and divide by the sensitivity value, which is the voltage per gravitational force, and it is 0.3 for ADXL345. Now talking about the next sensor, that is gyroscope sensor. A gyroscope sensor is a sensor that can measure the angular velocity of an object along one or more axes. Angular velocity is the rate of change of angle, and it can be caused by rotation, tilt, or spin. Gyroscope sensors are used for various applications such as stabilizing the orientation of a device, measuring the angle of a robot, controlling the movement of a drone, etc. One of the most common and easy to use gyroscope sensor with Arduino is L3G4200D or L3GD20H. Here in this particular example, we have taken L3GD20H 3-axis gyroscope sensor. There are different ways when we will do the experiment of gyroscope sensor practically. That time I will explain you how to connect this gyroscope sensor with the Arduino. Let's move further and we'll talk about the next sensor, that is a pressure sensor. A pressure sensor is a sensor that can measure the pressure of a fluid or gas such as air, water, oil, etc. Pressure is the force per unit area exerted by the fluid or the gas on a surface. Pressure sensors are used for various applications such as measuring the altitude or the depth, the speed, the force, the weight, etc. One of the most common and easy to use pressure sensor with Arduino is BMP180, which is a digital sensor that outputs a 16-bit value proportional to the pressure in pascals. The sensor also has a built-in temperature sensor that outputs a 16-bit value proportional to the temperature in degree Celsius. So whenever we need to sense the pressure, we can use this type of the pressure sensors. A pressure sensor usually acts as a transducer and it generates a signal as a function of the pressure imposed. Coming forward, we are going to talk about very interesting sensor, that is a light sensor. The light sensor is a sensor that can measure the intensity of the light, which is the amount of energy carried by the light waves per unit time and area. Light sensors are used for various applications such as adjusting the brightness of the screen, detecting the day and night cycle, measuring the solar radiation, etc. Here you can see the light sensor, one of the most common and easy to use light sensor with Arduino is the LDR, which stands for light dependent resistor. It is an analog sensor that changes its resistance according to the amount of light it receives. The more light, the lower the resistance. The more light, the lower resistance, and vice versa. To connect a light sensor to the Arduino, you need to connect one end of the LDR to 5-volt pin of Arduino and the other end of the analog input pin of Arduino. You also need to connect a resistor typically of 10 kilo ohms between the same analog input pin and the ground pin of the Arduino to form a voltage divider circuit. You can use the analog read function to read the values of the sensor, which will be between 0 to 1023, corresponding to 0 to 5 volt. To convert this value to a lux, which is the unit of the light intensity, you need to use the formula that depends on the type and the model of the LDR you are using. You can find the formula and the data sheet of your LDR online. So we need to do some calculation while using this LDR sensor in our programming. There are different type of light sensors available in the market, such as photoresistor, photodiodes, and phototransistors that work based on the principle of changing the resistance or current when exposed to the light. Now we'll talk about the next sensor, that is very interesting sensor, and it is called as color sensor. This color sensor looks like this. A color sensor is a sensor that can measure the color of an object or the environment. The color is perception of human eyes and brain of the wavelength and intensity of the light. Color sensors are used for various applications such as sorting objects by color, detecting the color of a flame, creating colors effect. One of the most common and easy to use color sensor with Arduino is the TCS3200, which is a digital sensor that outputs a frequency proportional to the color intensity in 4 channels: red, green, blue, and clear. The sensor has a color filter array that filters the light into the 4 channels of a photodiode array that converts the light into the current. The sensor has 4 current to frequency converter that converts the current into a frequency which can be measured by Arduino. There are different types of the color sensors such as TCS230, TCS3200, TCS34725, etc. that work based on the principle of filtering and detecting different wavelengths of the light. Now talking about the next sensor, which is a touch sensor. A touch sensor is a sensor that can detect the presence or absence of a touch, which is the contact or near contact of human finger or another conductive object. Touch sensors are used for various applications such as creating buttons, switches, slides, keyboards, etc. One of the most common and easy to use touch sensor with Arduino is the TTP223. TTP223, which is a digital sensor that outputs a high or low signal depending on whether the sensor is touched or not. The sensor has capacitive sensing area that can be touched with fingers or a metal object. The sensor has a sensitivity and a response time adjustment. The sensor has a sensitivity and a response time adjustment which can be changed by soldering or desoldering the pads on the back of the sensor. To connect a touch sensor to Arduino, you need to connect the power supply pins VCC and ground to the 5-volt and ground pins of the Arduino and the signal pin SIG pin to the digital input of Arduino. You can use the digital read function to read the state of the sensor, which will be either high or low depending on whether the sensor is touched or not. Talking about the next sensor, that is a vibration sensor. A vibration sensor is a device that detects vibration or movements in its surroundings. A vibration sensor can measure the vibration of an object or the environment. Vibration is the oscillation or the movement of an object around a fixed point or a mean position. Vibration sensors are used for various applications such as detecting the knock on a door, measuring the earthquake intensity, monitoring the health of a machine. One of the most common and easy to use vibration sensors with Arduino is the SW420. Here is the diagram of SW420, which is a digital sensor that outputs a high or low signal depending on whether the sensor detects the vibration or not. The sensor has a spring mass system that vibrates when the sensor is shaken or moved. The sensor also has a sensitivity and a response time adjustment, which can be changed by turning the potentiometer on the sensor. To connect to a vibration sensor with Arduino, you need to connect the power supply pins VCC and ground to 5-volt and ground pins of Arduino and the signal pin, that is DO or D0 pin, to a digital input of Arduino. You can use the digital read function to read the state of the sensor, which will be either high or low depending on whether the sensor detects the vibration or not. So in this way, we can use the vibration sensor. We can monitor different things using this particular sensor. Moving ahead, and we are going to talk about the next sensor, which can be used in different applications, and that is the water flow sensor. A water flow sensor is a sensor that can measure the flow of a water flow sensor is a sensor that can measure the flow rate of water, which is the volume of water that passes through a given area per unit time. Water flow sensors are used for various applications such as measuring the water consumption, controlling the irrigation system, monitoring the leakages, etc. One of the most common and easy to use water sensor with Arduino is YFS201, which is a digital sensor that outputs a frequency proportional to the flow rate of water in liters per minute. The sensor has a turbine that rotates when the water flows through the sensor. The sensor also has a Hall effect sensor that detects the rotation of the turbine and generates a pulse. To connect with the water flow sensor with Arduino, you need to connect the power supply pins red and black to the plus 5-volt and ground pins of Arduino and the signal pin that is yellow colored to a digital pin of Arduino, you can use the pulse in function to measure the duration of the pulses sent by the sensor and then calculate the frequency by dividing 1 by the duration. To convert the frequency into liters per minute, you need to multiply the frequency by a constant factor, which is 7.5 for the YF2S201 sensor. So this was all about the water flow sensor. Mostly these type of sensors are used in our washing machines also, so that the amount in fully automatic washing machines, when we need to measure the amount of the water required to clean the cloth, there we are using these type of sensors. The next sensor we'll talk about is the level sensor. A level sensor is a device that can measure the amount or position of a substance in a container or a natural form. A level sensor is a sensor that can measure the level of the liquid or a solid in a container, such as a tank, a barrel, or a silo, etc. Level sensors are used for various applications, such as measuring the fuel level, controlling the water level, monitoring the inventory also. There are different type of level sensors, such as float, capacitive, ultrasonic, etc. One of the most common and easy to use level sensor with Arduino is the JSN SR04T, which is an ultrasonic sensor that measures the distance to the surface of the liquid to the or the solid by sending and receiving the sound waves. The sensor is waterproof and can be mounted on the top or the bottom of the container. Now, talking about the next sensor, that is a gas sensor. A gas sensor is a sensor that can measure the concentration of a gas in the air, such as carbon monoxide, methane, alcohol, smoke, etc. Gas sensors are used for various applications, such as detecting the air quality, preventing the gas leakage, monitoring the breathalyzer. There are different types of gas sensors, such as electromechanical, catalytic, and optical, etc. One of the most common and easy to use gas sensor with Arduino is MQ. MQ1, MQ2, or different MQ series gas sensors are available in the market which can be used. These gas sensors are analog sensors that outputs a voltage proportional to the gas concentration in parts per million, that is ppm. The MQ series has different models for different gases, such as MQ2 for combustible gas, MQ3 for alcohol, MQ4 for methane, MQ5 for natural gas, MQ6 for propane, MQ7 for carbon monoxide, MQ8 for hydrogen, MQ9 for carbon monoxide again, and there are different MQ series sensors available. One more sensor I can remember, that is MQ135, that is for measuring the air quality index. So we can use this gas sensor to detect the gas. Now coming ahead with the next sensor, that is soil moisture sensor. A soil moisture sensor is a sensor that can measure the moisture content of the soil, which is the amount of water present in the soil. Soil moisture sensors are used for various applications, such as monitoring the plant growth, controlling the irrigation system, and preventing the soil erosion. One of the most common and easy to use soil moisture sensor with Arduino is FC28, which is an analog sensor. One of the most common and easy to use soil moisture sensor with Arduino is FC28, which is an analog sensor that outputs a voltage inversely proportional to the soil moisture. The sensor has two probes that are inserted into the soil and a current that flows between them. The more water in the soil, the lower the resistance and the higher the voltage. To connect a soil moisture sensor with the Arduino, you need to connect the power supply pins VCC and ground to plus 5 volt and ground pins of Arduino and the signal pin, that is AO, to analog input of the Arduino. You can use the analog read function to read the values of the sensor, which will be between 0 to 1023 corresponding to 0 to 5 volt. To convert this value into percentage, you need to map the values between 0 to 1023 to 0 to 100 and then invert it, since the voltage is inversely proportional to the moisture. Coming to the end part of this sensor, we are here and we are going to talk about the tachometer. A tachometer is a device that can measure the rotational speed or the RPM of a spinning object, such as a motor or a fan or a wheel. Or in other words, I can define it as a tachometer is a sensor that can measure the rotational speed of an object such as a wheel, a fan, a motor, etc. Tachometers are used for various applications such as measuring the speed of vehicle, controlling the speed of a motor, monitoring the performance of a machine. There are different types of tachometer sensors available in the market, such as optical, magnetic, Hall effect, etc. One of the most common and easy to use tachometer with Arduino is the KY033, which is a Hall effect sensor that outputs a pulse when a magnet passes near it. The sensor has a magnet that is attached to the rotating object and a Hall effect switch that detects the magnetic field and generates a pulse. This was all about different type of the sensors. Now we are going to do experiments with these sensors. But before experimenting, read more about the sensors. You need to understand how a sensor works, as well as you need to know about the different pins of those sensors and how to connect with those pins. Now in the next section, we are going to do different experiments with different type of sensors. Hello, now we'll start doing some experiments based on sensors. So the first sensor that we are going to use is PIR sensor. Let's start the project, and for that you need to go to tinkercad.com. First log in into your account, and then after go to designs, click on create, and then after circuits. You will get the workspace wherein you need to create your circuit. This is the workspace wherein we are going to create our circuit using the PIR sensor. So first of all, we need to ask for the component, and our first component is Arduino Uno. So we'll find the Arduino Uno, simply drag and drop that onto your screen, the workspace, and then after we are going to use the PIR sensor. So type PIR sensor on the component. You will find the PIR sensor. Simply drag and drop somewhere. Now the PIR sensor, as studied in the previous section, here the PIR sensor is having three different pins. The first pin is ground, the second is power, and third is signal. So the ground pin need to be connected to the ground pin of Arduino. Simply select that and connect that with the ground pin of Arduino. So here I am having the ground pin. So there I will connect PIR sensors ground pin like this. The second pin is the power pin that need to be connected with the 5 volt power supply. So simply drag and drop and connect that with the plus 5 volt power supply like this. Yeah. So let me change the color of the pin. That should be red. Now the third pin is the signal pin, and that need to be connected to any of the digital pin of the Arduino. So let's connect it with the pin number 8. So here we have created a circuit wherein we have connected the PIR sensor, but it will not be done, because when we want to see how it functions, then in that situation what we need to do is we need to connect some device. When the sensor will sense some obstacle, then that device should work accordingly. So here I am going to use one LED, and when something will come in front of the sensor, when the PIR sensor will sense something, then after that LED will blink. So simply here I am going to use one LED. For that I'll again go to the component section. I will type LED. I'll get an LED, drag and drop it somewhere. Now when we are using the LED, we need to use the resistor also. So I'll find resistor, connect the resistor to one pin, and then after, the anode will be connected to any of the digital pin. Here I am connecting this to pin number 12, and the cathode of the LED will be connected to the ground pin, which is here of the Arduino. So now the circuit is connected, my LED is connected. The positive terminal of, or you can say the anode terminal of the LED through a resistor is connected to the pin number 12 of digital, that is the digital pin of the Arduino, and the cathode terminal is connected with the ground pin. Now we need to write the code for this, and as per this circuit arrangement, what is going to happen is, when something will be detected by this PIR sensor, that particular time the LED light will glow. So let's start coding for this particular circuit. Go to the codes, and then after whatever circuit is there, you can simply delete that, and then we can start writing a fresh code here. So here we are using the PIR sensor, and whenever we are using any particular sensor, as stated earlier, we need to declare some variable wherein the data can be stored. So I'm going to declare a variable. Go to variable section of the blocks, and then after, click on create variable and give the name of your variable. Here I'm keeping PIR sensor, the name of my variable. So the PIR sensor variable is created here. Now we'll start going. This PIR sensor is basically a variable we have declared, and from that particular I need to take the input to the Arduino, and then after, based on that input, the microcontroller is going to decide what to do with that LED. So again, go to the input section. Yeah, so now I'll take this setup, and here set PIR sensor to pin number 8 we have connected. So for that we need to take the input, read digital pin 8. Okay, so what this particular code is going to do is, it will read the digital pin number 8 through which the PIR sensor is connected, and whatever value on that particular pin number 8 will come, that will be stored on the variable, that is PIR sensor. So this is all about the setup part. Now what we are going to do is, we are going to simply blink the LED when something is detected using this particular pin. So for that, we'll go and we'll take the control, we'll go to the control section, and we'll take the if else condition like this if else condition will take, and then I will put that simply over here, and then we'll give the condition that if the value of the digital pin is greater than 0, then something we need to do. So that condition I need to put over here, and for that I will simply go to the mathematical tool, and there I'll find something through which I can write something. So here, this one I'll select, I'll put over here, and if pin number 1 or the variable, I can put if PIR sensor is greater than or equals to 1, then we need to blink the we need to switch on the LED. So for that, set pin number 12 through which we have connected our LED, pin number 12 to high, else set pin number 12 to low. What this particular code is going to do is, at the beginning we are defining that digital pin number 8 will hold all the data into our variable, that is PIR sensor. And if the PIR sensor value is equals to or greater than 1, then pin number 12 through which we have connected the LED will be high, otherwise the pin number 12 will be low. So it means that whenever something will be detected through this PIR sensor, the value will be definitely more than greater than 0, and then in that situation the LED will blink. So let's see what happens in this particular. Yeah, like this. You can see the LED is blinking when something is detected. Now the LED goes off. Again, I am sending something like this. When some movement is there, LED is blinking. Now here what we can do is we can stop the simulation and we can write the code that set pin 12 to high for some particular time. So we want to keep whenever someone is coming in this particular range, then the light will glow for, let's consider, for 2 or 3 seconds. So that we need to keep, and for that we need to provide the delay. And to provide the delay, we are going to go on the control section, and then we will put the wait condition, and here we'll put that we'll wait for let's consider 2 seconds, and then after we'll switch it off. Similarly, when after low also we'll wait for 2 seconds. So in this way, now we'll see how it functions again. So you can see here in the diagram that at the moment the bulb, the LED is not glowing. Now I will put something in the range of this PIR sensor like this. So I am moving something here. So you can see here the LED is blinking. I have left it. Now after 2 seconds, it goes off. So in this way, when some movement is detected through the PIR sensor, immediately the LED will blink. And when after 2 seconds, that particular LED will goes off. So this is the way how we can use a sensor, and this type of the circuit can be used at your home. I hope this tutorial will give you all the information about the PIR sensor, and you can do the experiment using the PIR sensor. So if you like this video, give me a thumbs up and don't forget to subscribe my channel. Thank you.